Okay, I have opened the ball data set. I'm just going to take a quick look at some of the things that we could do with this data. So this was a student experiment where they were looking at, well, they looked at a couple of things. They looked at how long it took a ball to come to rest if it was dropped onto different surfaces from different drop heights. So we've actually got a few outcome measurements here. We've got the height of the first bounce, the first rebound height, and the number of bounces. Just for simplicity, I might ignore these ones and look just at the time to rest, this column. And what we would be interested in is there a difference in the ball types, and you could do some plots of these. So we've got golf, tennis ball, soccer ball, and there's a few others. Obviously we would expect that the higher you drop it from, the more it's going to bounce and the longer it will take to come to rest. And we've also got these different bounce surfaces, concrete, carpet, I can't remember what the other ones are, they'll show up in the graphs. So it'd probably take a little bit of time to do some individual graphs, which would be definitely worthwhile. I'm just going to do one quick graph of a few things together and then I'll look at running some models. So in graph, I'm going to go to scatter plot and I might just do the with groups. So my response variable is time to rest, so I will add that into Y. My main covariate will be the drop height, and the categorical variables, which I think are important, well, there's only two of them anyway, will be the ball type and the bounce surface. Okay. So there might be a little bit too much going on here. Maybe I'll do this again without the bounce surface. There's always a bit of a conflict when trying to look at a lot of variables at once, in that it's just really hard to visualize more than about 3 variables at the same time. It's not impossible, but it does become a bit of a challenge. I mean, we've got the same pattern of points here, but we've just got some fewer colors, which hopefully will help us out a bit. So it looks like we've got our golf balls are taking a long time to come to rest, but it might be that we've got, I can also see these squares down here, so this might be the different surfaces. I can imagine that if you drop a golf ball on concrete, it's going to bounce really high and bounce for a long time, but possibly if you bounce it on carpet, it hardly bounces at all, so that might be where we're getting a really different response. So based on the fact that it already looks like there's a different response here, I'm pretty sure I'm going to need an interaction term. It looks like the time to rest for the ball, there is a difference depending on which surface you're dropping it at. Super ball, I don't know what they might be the high bounce balls, not sure. Soccer, golf, it's hard to see what's going on here because there's so many points. So that, I might leave the plots there. If you were investigating this data, I'd probably recommend that you look at each pair of variables just to get a really good idea of what's going on. So now I'll look at running the model. So I'm going to go to Stat ANOVA General Linear Model, and I will start off with the basic model. So that would be time to rest. The factors are our categorical variables, the ball type and bounce surface, and our covariate is the drop height. For our graphs, I'm going to use the standardized residuals. I'm going to use the 4 and 1, and we could also do the residuals versus some of the variables. So it's possible we might want to look at the residuals versus the drop height as well. Now I do think I need an interaction term here, and it's possible that we need a curve as well, a quadratic. Depending on how much math you have and how much you remember from high school, you may not be comfortable with that. So I'm just going to do the basic model to start, and then we'll look at adding a couple of extra things in. So the residuals versus the drop height. There's something going on here. We've got this increase in variance, so I'll just keep that in the back of our minds. Probably more interesting is the standardized residuals versus the fitted values, and it looks here like we've got a curve coming out, and this is pretty obvious, I'm going to say. Like, there's a clear pattern there. They're definitely not randomly scattered about. If we look at the normality, again, they really don't look normal. They're not following that straight line at all, and the histogram, we can see there's something really weird going on here. So that does not look normal either. In this case, we can see something coming out in the observation order, but I don't think it matters. So what we're getting is this clustering of observations up here, then down here, another cluster, and if you think about the experiment that they were doing, and we can do this by looking at the data, they were doing their experiment in batches. So we've got golf, 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 then tennis, 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 tennis. So this pattern coming out is that the golf balls are all doing one thing, the tennis balls are all doing one thing, and until we completely adjust for that in this model, we're going to get these funny patterns coming out. So this may disappear once I have a look at the interaction. And this curve, the only way to test for that would be through adding a squared term in, and we can do that as well. So we'll take a quick look at the model, but I'm not overly interested until I fix up some of these details. So if we just scroll up to the top, everything is significant. Drop height, ball type, and bounce surface, and that doesn't surprise me. We've got a pretty good R squared, 50%. I'm not going to look at the coefficients at the moment. Something worth noting here is that we do have these unusual observations, and this is what we could see in our plots. You can see here we've got these unusual observations there. We can also see them here. So there's something going on there that we haven't adjusted for. So the interaction may help fix up these three plots. Adding in a squared term may help fix up this plot. And how comfortable you feel with this and whether or not you want to try something like this with your own data really depends probably on your experience and how happy you are with the math of it. If you want to try looking at these, I think you can try adding them in on the graphs. I haven't been using Minitab recently, I've been using SPSS, so I'm not entirely sure. Let's try simple with regression and see if we can add. So under regression here, we do have this linear which we've been using, but we've also got this quadratic. And a quadratic is a simple curve. Usually we think of it as being a smile or a frown. So a very simple curve. And here we've got a smile. Anything that looks like a smile or a frown, you can put in a quadratic. A cubic has a bit of a wiggle in it. So it'll do. And that's, I wouldn't use that, especially when starting. So we could use a quadratic. I haven't put my variables in. So that would be the time to rest, and the x variable would be the drop height. So let's have a look at that. So you can see that this line now has a very slight bend in it, and it's actually not fitting very well, but I think that's because of these golf balls up here. If we did this plot, and I think we did in the simple linear regression week where we just looked at one type of ball, this would be more obvious. Here it's coming out in the residuals, but it's not very obvious in the graphs, and that's why it's so important to look at the residuals. Those golf balls, gosh, they cause problems. Right, let's have a look at the model. So to add this into the model, so if you remember, we've got two things we want to add in. So with the drop height, we're interested in the curve, and this is from the second row, terms through order. This is probably not very intuitive if you don't have a lot of math, so I'm just going to add that in. And you can see that it's added in drop height times drop height. This is the squared term, and this is what gives you the smile or the frown in the data. The other thing that we're interested in, which we did with the cholesterol data, is the interaction. So I'm going to select ball type, then press shift and select bounce surface and add in this interaction. So now we've got our curve and we've got our interaction. Okay. So that's actually looking a little bit better. We don't have the increase in variance like we had last time. This is, it's not perfect. We've still got some extreme observations, and I'm going to guess that's the golf balls still doing that. If we have a look at our residuals, again, still not perfect, but it's looking better. So we have this clump of variables here, and then we've got this one. And again, I think this is probably the golf balls. The observation order, this is all largely fixed up apart from the golf balls. And our residuals are looking much more normal now, but we do have some extreme observations. So anything less than -3 or higher than +3 would be extreme, and we've got this wiggle in here. And we can see these extreme observations coming out here and here, and they showing up here on the observation order, and that was most likely these ones here and here on the fitted values. So you get the same patterns coming through in each of the graphs. This is the golf balls. They are causing real problems, and I think that's because if you bounce a golf ball on concrete, it goes miles and bounces for ages, but if you bounce it on a carpet, it just goes plop and stops. So it's behaving very differently to the other balls. So this would be quite different if you took the golf balls out. If we go to our model, so this is looking better than before, just to repeat that. So it's looking better than before. We've reduced the curvature, the residuals are looking more normal, but it's still not perfect. We still have our unusual observations that are coming out as being, it just says unusual. It means they've got a large residual. So that's on the plot. That's these ones here at less than -3, and these ones here at greater than +3, the tail ends. Got a whole lot of equations. Scroll up, scroll up, scroll up. And here's our model. So we've got everything is significant. So for our interaction, if I highlight that, it says, oh sorry, not interaction, this is our quadratic, this is our curve. The drop height times the drop height is a squared term. The null hypothesis is that there is no relationship between this term and the time to rest. We've got very strong evidence against that, and therefore we should keep this term in the model. The next row is our interaction, and this says the null hypothesis is that there is no interaction between ball type and bounce surface. So that says that it doesn't matter what bounce surface you're on, the ball type will always have the same impact, or maybe the other way around. It doesn't matter what ball you're using, the bounce surface will always have the same effect on the time to rest. Clearly that's not true. We've got a highly significant, we've got a very strong result here. The p-value is very small. Our r squared has jumped up hugely. So before, I don't know if you remember, if I scroll up, we were only explaining about 50% of the variation in the data with the model. So we could only explain about half of what was going on with these three variables as is. Once we add in the curve and once we add in the interaction, we can now explain 94% of what's going on, so nearly all of it. So this is a huge improvement in the model. Pardon me. So the only thing that left to do really would be to try and fix up this issue with the golf balls, and I think that's probably a little bit too advanced in this case, so I would just leave that here. If you've gotten this far and you're with me, you've done great. You could do a little bit more with these golf balls, or you could take them out and model them separately. So the model's still not perfect, but I think we've done a pretty good job in explaining what's going on. In terms of presenting these results, obviously you could use your coefficients if you want to explain the size of the effects. You could look at your p-values, and I think you would probably also want to show some, you could look at some box plots, but you could look at some interval plots as well, so your means with your confidence intervals. So I would look at the time to rest, and we could try doing them both together, ball type and bounce surface. Maybe it would be easier to do these separately, I don't know, I'll leave that to your judgment. You can try it the other way. But here we can see that we are where the differences is. I guess it's a little bit hard for this first lot. But we can see that the soccer balls are bouncier, the super balls are bouncier than the cricket balls. The golf ball, this is our problem child up here. You are to blame, golf balls on concrete. So this is causing all the issues with the data, but apart from that there are some trends which you could probably look at in some other plots.